So far you know how to take derivatives of lots of different kinds of functions, and because of the sum and difference rule, and the product rule, and the quotient rule, you can also take the derivative of all of those different kinds of functions added, subtracted, multiplied, or divided together. So why do we need another rule? Because a lot of the most interesting functions come from letting the result, the output of one function, be the input to another function. So that way of combining functions is called composition. So we need the chain rule to help us take the derivative of functions that are composites, or functions that are a result of composition. So the chain rule, there's two different ways to think about it. It can sort of show up in two different scenarios. So the first version I want to look at is the first version I have on this paper here. And that's when you're using function notation when it's obvious, well, more obvious, that two functions are being composed together. So if I have h of x is a composed function, so f of g of x, then to take the derivative, h prime of x is f prime of g of x times g prime of x. And probably the most convenient way to remember that, or to think about that, is h prime is going to be the derivative of the outside function with the inside the same. So see, I have the derivative of f prime, but the g of x part, the input to f prime, is the same as the input to the original function. And I'm going to multiply by the derivative of the input. So the derivative of the outside, with the inside stays the same, times the derivative of the inside. So I actually want to start with this example down here. If h of x is sine of x squared plus x, so question number one, question A. If we're going to think of that as f of g of x, what's f and what's g? So it's a little bit like the warm-up question I asked the other day. So I would say that, f of x, the outside function, is sine of x, and the inside function, g of x, is x squared plus x. So if you can identify those two separate functions that are being composed together, then we're going to use the chain rule to take the derivative. So question B says find h prime of x. Well, h prime of x is f prime of g of x, so the derivative of the outside function with the inside still the same. The derivative of sine is cosine. So f prime of g of x is still x squared plus 2. Nope, it's x squared plus x. And then I'm going to multiply by g prime of x. So multiplied by the derivative of g in this case is 2x plus 1. So h prime of x is f prime of g of x times g prime of x. So cosine of x squared plus x all times 2x plus 1. Here, now I've been asked to find h prime of 0. I already have an expression for h prime of x, so to find h prime of 0, I'm just going to replace all the x's with zeros. That's going to be cosine of 0 squared plus 0 times 2 times 0 plus 1, 2 times 0 plus 1. So that's the cosine of 0 is 1 times, this is 2 times 0 plus 1. This is just 1. 1 times 1 makes 1. We'll do a couple of these examples from the back side of your paper. So if f of x is sine of 2x, I want to take the derivative. This is the function sine of x on the outside and the function 2x on the inside. So f prime of x, the derivative of the outsides, the derivative of sine is cosine. The inside function stays the same, so cosine of 2x, times the derivative of the inside function. The derivative of 2x is 2. If you were on taking the multiple choice section, that 2 would be written out in the front, and you'd have the answer 2 times the cosine of 2x. On the free response version, feel free to leave your answer in any form that's convenient to you. Try number 4. So this is the square root of 5x. That's the same as saying 5x to the 1/2. Well, how do I take the derivative of something raised to the 1/2? The prime of x is going to equal, I'm going to bring that 1/2 to the front, 1/2. Whatever was getting raised to the 1/2, which was 5x, is now going to get raised to the 1 less than 1/2, which is negative 1/2. And then I'm going to multiply by the derivative of the inside. Well, the inside in this case is the thing inside the radical. The derivative of 5x is 5. Take a look at number 8. Just remember that this notation, we read it cosine cubed of x, but it means take the cosine of x and cube that result. So how do I take the derivative of something getting cubed? Well, the derivative of x cubed would be 3x squared. So we're going to use that same pattern. F prime of x here is going to equal 3 times cosine of x, which was getting cubed. Now it's going to get raised to the 1 less power, so 3 times cosine of x squared. And I'm going to multiply by the derivative of the inside. Well, what's the derivative of cosine x? That's the opposite of sine of x. And now here's the reason the chain rule gets the name chain rule. Sometimes we have complicated functions that aren't just 2 functions composed together, but they're actually 3 or even more functions composed together. So to do that, we're just going to follow that same process to take the derivative of a bunch of functions composed together. It's the derivative of the outermost function with the inside the same times the derivative of the inside. Well, to take the derivative of the inside, you might have to take the derivative of the outermost function of the inside, with that inside still the same, times the derivative of the inside. So just as an example here, g of t is tangent of 5 minus sine of 2t. So to find g prime of t. So g prime of t is going to be the derivative of the outside function. In this case, the outside function is tangent. So the derivative of tangent is secant squared of, and the inside stays the same, 5 minus 2 sine t. I'm going to multiply by the derivative of the inside. Well, the derivative of the inside, that's the derivative of 5 minus sine of 2t. Well, the derivative of 5 is 0, so I don't have to worry about that. The derivative of negative sine of 2t is negative cosine of 2t. That was the derivative of sine with the inside still the same. So the derivative of sine is cosine. The 2t stays the same. And now I need to multiply by the derivative of the inside. In this case, the inside was 2t. The derivative of 2t is 2. If this were the free response section, feel free to leave your answer like that. Notice we do need parentheses around the negative cosine of 2t, so it doesn't look like I'm subtracting cosine of 2t. If you wanted to pretty it up, if you were taking the multiple choice section, the answer I would expect this is a negative and a 2. I would expect this equals negative 2 secant squared of 5 minus 2, 5 minus the sine of 2t times the cosine of 2t. There you go. That's a chain that has 3 pieces and 3 links in it.